What up? It's Papa Bale's pulse motor. So this one is a little bit smoother running. I like this one a lot. See how easily that moved? But watch, once it gets going, man, it's not going to move at all. There we go, 12 volts in. 200 milliamps. Between 100 and 200 right now. And the other thing I got hooked up here is I got a signal generator hooked up to the trigger strand, so it'll pulse the transistor whenever this pulses. Very smooth. $400 milliamps. I think that's its max. So smooth. Hello, hello. I know it doesn't look like it's moving, but it's moving really, really fast. You can see how straight that is. It's awesome. Hey, Paul. So I do have somewhat of a tack strip on the outside rim of this. So let's see if I can get a reading. It's wrong. Let me show you what I got. 81,000. That's awesome, but I think this battery is finally charged up. This little one, it was dead. This little battery was dead, but I think it's revitalized, actually. And you know how you get the backlash on your power supply from the wheel just spinning once you turn it all the way down? It was at like 5.5 volts. It's a lot.
Lapman says, "What are we doing?"
We are revitalizing batteries that are dead currently. I wish there was a way for me to show you like really what's going on here, how fast this is going. I'm going to try turning on the signal generator now. It's tied to the trigger strand. Let me see what happens here. All right, I'm going to get it moving first. It sounds all right to me. So this, when I started rejuvenating it, was at 7.5 volts. And it was fluxing, all fluxion. All right, now I'll turn the signal generator back on. Let's see what happens.
Where did you learn this stuff?
YouTube. Learned it on YouTube. This is 800 hertz being pumped into the trigger strand. You can hear the difference when I go to 700. $600. Oh, that's 800. 600. Look at that. That is going so fast right now. This is 1 kilohertz on the trigger strand. So every time the magnet passes the coil, we unleash a kilohertz. So that happens 3 times a rotation. And wow, man, it generating so much, so much. All right. Cut that off. Saw that go down about 5 volts.
How do you ask, what are we making?
We're getting the correct measurements. We're revitalizing a couple batteries, but ultimately we're going to be doing a closed loop circuit where we're charging and running the system with the same battery. But we're just taking steps to get the best way we can get there with the stuff we have. We're not building anything else. We're not making anything new. We're just using what we have. We have a bunch of stuff though. So this is the coil that we're currently testing. It's a tri-filer coil. It's got 20 gauge, 18 gauge, and 32 gauge. I'm using 32 gauge as a trigger and the 20 gauge as a drive currently. What I'm thinking about doing is making the 18 and the 20 gauge a single drive, getting rid of the tri-filer, and making it a bifiler coil. Excuse me. Um,
All right, we got a question. Would you start working with pulse motors at home if you had the time and the correct info? We got 4 votes for yes.
awesome. Awesome. Yeah, absolutely. Try to get the best info you can. In order to get to here, I went through a lot of, you know, people would come to me. I'd make a video. They'd come to me. They'd give me their advice. And this is, it's been an evolution. I found out about kenergy.store. That's a great place to get some equipment to run your own tests. It's really cool stuff. This is an SSG. Make sure it's in the shot. Yeah, it's there. This is an SSG with combo, generator combo. So we're utilizing the negative spike off the coil, or the collapse spike, with the reverse diode, and the throughput from the input is going through the straight diode. So all that energy is being utilized, which is good. I mean, you can see how fast this thing goes. It's amazing. With the gen. That's awesome. And then of course we have the signal generator hooked up, which is bolstering the output by a lot. Um, I'm thinking about where I'm going to set this thing up to. I think I'm just going to clip it to the output. Well, currently it's hooked up to the 18 gauge, the trifilar strand. Let's see what data we're going to get from that. Okay, let's turn it on. And this is an 18 gauge trifilar strand, so we're not going to get any like high voltage off of it. We'll get about 5 volts, which is okay. But what I'm trying to point out is that if you watch the oscilloscope here, see, I just turned the signal generator on, went up 5 volts. Boom. Like, wow. Okay? You see what I'm saying? That all I had to do was push a button and it went up 5 volts legit on the trifilar. So putting more hertz through it when it's open, um, generates more voltage. Uh, but there is a resonance there. There's a, what do you call it? Where the voltage is the highest, and sometimes it's not just continuously going up on the knob. There's a range there. Resonant frequency. There's still a resonant frequency for what you're putting in. That's awesome. Here, for the turn it back on for the, and it'll help break it. It'll slow it down. You can hear it. Like, whoa, slow down. So that's why I think that running the signal generator through the pulse motor improves the torque, like by a lot.
Drew says I need to replace my bypass line. Drew Miller.
Okay. What are you bypassing? See, I know what you mean, because if you look right here, there are 4 screws after the 4 screws that you use to plug your bifilar in, which means that there's room for a resistor, and then there's room for a pot. But if you go from resistor 1 to pot 2, you can bypass having to put either a resistor or a pot in there. You can put one in there. You don't have to put them both in there. You can definitely put them both in there, but I need to get a better pot before I start messing around. Anyway, I know what you meant by bypass. I hope you're not talking about a heart thing.
Hmm.
Alright, so the signal generator is still on. We're at 12 volts, and you draw more amperage with the frequency being so high. So we're at 0.8, 800 milliamps. So that might not be a good way to do this. You get 5 more volts for virtually 500 milliamps more energy spent. That's not a deal. That is bad. Still cool though. Signal generator does increase the voltage output. There we go. Makes me wonder what would happen if I just ran the regular SG one, how fast it would be going. And so when I turn it all the way off, we still get the collapse for each magnet. And it looks like it was double bounding because there's 6 of them and there's only 3 magnets. So I don't know exactly what that means, but there's definitely more spikes there than there are magnets on the wheel. So that's with 97.5 ohms of resistance. And a kilohertz in on the signal generator. And this is on an 18 gauge strand, so this is on a very thick wire. We'd be getting a lot different reading if it was a 20 gauge strand, probably a lot more spiky.
Alright, we got 19 volts, 79% gas.
Awesome. Maybe I'll do a breakdown of like the bare minimum of what you'll need. Trying to keep it as inexpensive as possible. That was whipping, so I just decided to cut it back. The battery that I'm revitalizing is slowly getting better. It's like, if we can get up into the 12 range with the charge, that'll be great. That means it's working. It's fixed. All right, so you get the negative spike here with the signal generator on. Let me turn it off. Let's see if we still get it. Nope. So that whole spike situation was happening because of the signal generator. Now we're only getting 1 spike. Let's see here. There they go. Just need to. All right, that's without power. That's without power. And that's what it looks like without the signal generator on. It's a pretty nice little sine wave spikes going on there. It's a little on the negative side, but that's okay. Now, do you see it change? Woo! Then it's got the signal generator also acts as a very good brake. Very cool. I love this wheel though, man. It spins phenomenally well. It's got two ceramic bearings of the appropriate size, 1/4 inch bore ceramic bearings. And I mean, it doesn't take much to move this, and it does not move at all. It's great. The only thing that's shaking is the shaft, and it's because it's really long. Oh, it's shaking a little bit. I can see it now. But you got to get it going again. It'll stop shaking. And sometimes the shaft will start spinning too because it's being held in place by bearings to get it perfectly centered. Sometimes if it gets sticky in there, it'll grab the shaft and it'll start to spin. I gotta say that's gotta be in between 1,500 and 2,000 RPMs right now. Wish I could get an accurate reading on that. Yep, there we go. 1823. I had the trig on stop. I don't know. I hit the wrong button. Uh, But could you imagine, like, if I had a thinner wire under there, what the oscilloscope would be saying? Man.
Woodsy Fox says, I've been watching you from time to time from day one. I love to see how far you've come. Keep up the great work.
Thank you. Thank you. I have come a long way. I really appreciate you noticing that.
And did you shift, did you make shift your own electric motor, buddy?
I did, sir.
Yes.
It's a generator, too.
All right, we now have 26 votes, 73% yes.
Nice. Awesome. So I gotta, like, either make kit or make a presentation on how to do one. It's gonna have all the necessities, man. It's gonna have your resistor, your pot, your light, your transistor, your rotor, your stand, your shaft.
Congrats on 4 million views.
Thank you. Awesome. See there, another shaft is spinning. I had to spin it. And it doesn't have to spin. That's the whole thing. It just gets, if it's bounding so fast, it can spin if it needs to. It's only when it gets going really fast. So you have your potentiometer, you'll have your transistor, you'll have your diodes, you'll have your resistor. Um, you have, for me, one option on how to set up your circuit. You got kenergy.store. He's got a lot of ways. He's really good at doing this stuff to run your circuit. And this circuit right here, the one I'm running this on, is from his store. So that thumbs up there. That's kenergy.store.
All right, we got a super chat.
Nice.
I am an industrial electrician. Also worked in an electrical motor repair shop for 10 years. I have an idea on what you're doing. And that's T Fear, $6.99 Canadian. Thank you, sir.
Thank you, T Fear. I appreciate you. I am planning on turning this into a closed loop system using this battery. I don't know if you can see that. No, it's kind of behind the wheel here. But it's right there. It's a 20 amp hour. It's not a deep cycle. It's an EXP 1220. Or no, 12,200. My bad. 12,200. Yeah, I got two of them for a good price, so I know they aren't deep cycle. Um, but I want it to run for at least 2 days before it drops below, a rate where it's gonna just continuously fall, like free fall. Uh, the last time I ran this, I got like 35 minutes per 100th of a drop in voltage. So at least for the volts we were going through at the time, it was like 35 minutes per change in the meter. All right, I'm gonna check my cap bank real quick. And then if it's low, I'll charge it instead of the battery. We'll see it, because the battery is a good load, but the battery is the different load than the cap bank. And different loads have different requirements. We'll see if the wind spins as good as it's been spinning. All right, so the cap bank is at 13 volts. $13.07. It's a 16. Yeah, it's pretty full, actually. And I might use the little battery instead of the big battery in the closed loop system. So for the closed loop system, we're going to have it pass. We're going to have the energy go in through the battery, out through the output, into the cap bank.
The internet's out. This is good, but that's out.
Okay. Our internet just crashed. Is the thing over there has got a white light on it?
Yeah.
Okay, it'll come back. But I'm glad we're still online here.
All right, here we go.
All right, we are hooked up to the cap bank. So we're going output to this little cap bank to the bigger cap bank.
T-Fear said, cool, just a scope on the right meter, or is that a PQ meter?
It's a multimeter with an oscilloscope.
I have a Fluke 43B. It's almost as old as I am. I used to troubleshoot a lot with it.
Fluke is good brand, man. I almost bought a Fluke. So we're getting a good charge on the cap bank. That's awesome. But you can see how on the oscilloscope, the spike is now on the top instead of the bottom. There goes the shaft.
What brand of meter is that? You mind me asking?
Oh man, I can't really read it. It's a Bestco, ABEST, a Bestco. Ha! I get it now. A.
It says a PQ is a power quality meter, harmonic scope, power measurements, all that stuff.
Oh no, I'm good. I'm good, man. I'm not looking to spend any money right now.
How much does one of those PQs cost?
Yeah, how much does a PQ meter cost? And I mean, see, and you go out and you buy all the fancy meters and all this other stuff, and you show everybody what's going on, and it still is going to drop. So, I mean, if you're buying all that stuff as your goal is to make it not drop, don't do it.
I bought mine used, single phase one.
Yeah, that's steep. Uh, I bought this one for 43 uh, American, 43 United States dollars on Amazon.
They go on eBay for about 3-4K still. The PQs.
Oh, okay. The PQ meter. Yeah, I don't know, man. It sounds pretty interesting. And maybe if, things turn around, I'll be able to get all this cool stuff. All right. So, to set up the closed loop system, and I think this wheel will work for it. Whatever we do, the wheel will work fine. With this coil at voltage, so you want it to be between, I'm thinking between zero point 0.3 and zero point 0.1 milliamps. So, no, zero point 0.3 and between 300 and 100 milliamps. That's what you want. Yeah, that's what we got. So that's awesome.
Says that's pretty cool. That's pretty good. This one can data log too. I use it for other things.
Oh, data logging.
Yeah, I haven't went ahead and done it yet. I bought it with the intent of the side business. Side hustle.
Side hustle.
Yes.
Awesome. First, I gotta know what I need it for, honestly, and then I gotta save up the money to get it. It sounds like I do want one though, and I just don't know it yet.
Yeah, measuring the harmonic scope power measurement.
And then I want a magnetic field reader as well. I've seen SNQ playing with that on his channel.
You wouldn't need it for this.
So that's a really small amount of 20 gauge that's running this right now. It's like 300 turns, 20 gauge. We are drawing 500 milliamps on it. 400 at 12 even. So, if it's above 12 volts on the power, it's going to probably drain more than 400 milliamps. To
There's
run
got
it.
a couple of shorts on that meter on YouTube,
Nice.
and there's honestly not that many videos about it on YouTube.
That's great. I'll check them out. Heck yeah. See the shaft start to spin there. Alright, now here's the question. I have two cap banks here. I got a super cap bank and then I've got an AC/DC cap bank. Which cap bank? I think I'm going to use the little cap bank because I don't see the big cap bank as having any directional flow. But I guess if it's in a loop, it'll flow automatically, pretty much. We'll see. Alright, we'll use the big one. But let's get this hooked up. We plug in the big battery here. We are setting up our closed loop system now. I think we have a good, and I think our goal wants to be either a day and a half or 2 days. But I don't know if it's going to do that. I think it might only go 6 hours.
It's like Jonathan dropped in and said, I mentioned making the shaft shorter yesterday. I never imagined we'd make it even longer.
That's awesome. I never imagined. Just for you, man. Just for you. All right. So we got the output going here to here. And then I think what we're going to do, and we have diodes in these ones, these connectors. We're going to go from here. And the reason I have diodes in these ones is because I've tried connecting this raw connection and you get sparks when you connect the last connect. And if you connect with sparks, you're going to get smoke. And you get smoke every time. And you don't necessarily know where the smoke's going to come from. Because you're like all over the table here. I mean, one end of the table is one end of your project and the other end's the end you're working on, and you get smoke. We'll see if we get a good return on this, and if not, we'll try removing the diodes, but I think what will happen is what I just suggested would happen. Okay, now we take the power input and we plug it into the battery. Let's see what happens. This is with 97 ohms of resistance. Okay, so it's rapidly dropping. And I think it's because I don't have a good pot. It's not rapidly dropping, but it's dropping pretty fast. So I got to get the pot hooked up. And I think what I'm going to do also is remove the big cap bank. We'll just have one cap bank. let me get that pot hooked up. I can't find the screwdriver.
It wasn't. I think you took it.
Yeah, it did. Oh man. Where did I put it? So much stuff. I think I'm gonna have to reconcile everything. I think that's what they call it.
You do an inventory.
Yeah, do an inventory. Personal inventory of my stuff here.
That's my gear.
Huh. That's so frustrating. Yeah, I just grabbed it. Where did I put it? I'm feeling pretty good. It's not like wow.
Yeah, like it just vanished from the brain base.
It just vanished into thin air. Like, where could I have put it? Maybe it's in the bathroom.
Is it in your pocket?
Just check my pocket 8 times.
You check his pocket 8 times. Right here.
Nope.
How about this one?
Yep.
All right.
Thank you, sir. My brother, he's the man. He found it. We can hook the pot up. And this is, the signal generator is going to cost too much. So that's a different experiment. We'll run just the pot. I think it works. I just don't think it works the way a 10-turn pot works. Not even close. You won't even get the same harmonics from it. You're not going to get the same sound effects from it. It's always going to sound different than one of those little ones. Come on, man. All right. So we just got to hook the ground up. right, let's turn it on. Well, let's get this kind of somewhere in the middle with some resistance in it. All right, let's turn it on. Huh. Oh, duh. So do we want to just go straight to the battery? Or we want to test it on the power supply? Oh, we're going up a little bit. Woo! Yeah, so it's this pot, it's all the way open now. There's no resistance except for the foundational resistance of the pot. And increasing the resistance will only slow it down
I heard that.
and increase the cost. So I don't understand.
What kind of horsepower does the pulse motor have? From William.
One or two, maybe three. Sometimes if you get a really good one, you get 4 or 5. I mean, if you get one going fast enough, you can cut your grass with it.
What kind of practical purposes can come from this? Mowing the grass would be one. Lights.
Depending on what you believe, you could make a time machine out of something like this.
Time machine.
Time machine, is that practical? I don't know. I mean, if you're yanking my crank, I'm gonna yank yours back. Practicality is overrated. And I'm running this on a battery, so don't quote anything about wasting stuff, because I'm
No
not
crank
wasting.
yanking here.
No wasting. I don't waste.
Yeah, he reuses a lot. He'll dismantle one previous one to make the next one work.
Yeah, man, I reuse everything that I have. I don't just swallow and waste. I don't just do that.
And say this is for fun and experimentation also.
I do this for fun and experimentation, and I've grown. I didn't start out doing anything with electricity. It was only magnetism when I started. Permanent magnetism. But it's been like 3 years now altogether, and I don't know. This is where I ended up. I wanted the wheel to spin on its own without me having to spin it, and have all that permanent magnetism do what it does while spinning. You know, it came from a desire from wanting to spin a disc. Let me show you what I'm talking about.
Is there a limit to the size you can make that?
That's a, what's it called? Relative. Very relative to who you are, how much money you have, and where you can set it up at. But you can make one of these the size of a craft if you want. See, this is one of the first things that I made like 3 years ago. And what it does is that it fits in with another disc that has, you know, these type of magnets, and they fit in between, and then, you know, it'd be on top like this way, and then one would make the other one spin. I wanted this all to happen, you know, on its own, you know, like to have a piece of art basically that spun and was all hooked together through magnetism. That's what started it all. But like every piece of clothing, I ended up having super glue on it, and it was just a big mess doing it that way. Then I got into 3D printing. I printed a few rotors, actually quite a few rotors. I printed some stands. I buy the shafts though. The shafts got to be solid, so you don't want to print a shaft. You really don't.
We got 40 votes now, 70% yes.
Awesome, awesome. So you guys are saying that you want to engage in building pulse motors. That's awesome. You know, when I first built it, I had no idea that it was called a pulse motor. I didn't even know that. I didn't even know it was called a brushless motor. Literally, I knew absolutely nothing when I built my first one. I got a lot of the questions that you normally get, like, what is this? What's the purpose? What's your intentions, man? Dude, I just wanted the frickin' wheel to spin without me spinning it.
That's natural. That's a natural match.
It's a natural want, a desire. Yeah. I think a lot of people want to see things spin. And that 46 on this meter just was about 10 minutes long. So that's awesome. We'll see what 45 does. There is a little bit of resistance on there, so I'm not going to mess with it. Because the only way that it's going to go and make any difference is less resistance. So I'm just going to leave that on there. Because I think we're getting more generation with the resistance on.
What about the RPM?
I'm thinking it's going about 1500. It was 1800 when I was testing it without stuff. So let me find my tach meter. Alright, I got my screwdriver in my pocket. Just need to find my meter. That's awesome. Maybe I won't find my meter. But I'd say it's going in anywhere between 1400 and 1600 RPMs right now. Maybe a little less, 1300. That is really weird. I just had it. I just took a reading with it. Yeah, I don't know, man.
The sample meter.
Yeah, I'm just about ready to say I don't know. I don't know. You want to know how fast it's going? I don't know.
We don't got. Where's the tool? Yeah.
They obviously don't want me using it. But that's awesome, man. This is a closed loop system going right now. We got battery over here, and then that goes to the SSG, and then from the SSG to the output, which goes to this cap bank, which is then connected back to the battery. $12.45. Oh, there goes 4.4. All right, that's another. That was a little bit less time. All right, 4.4. What time is it?
11:46.
11:46 for 12.44. I'm gonna write that down.
It's something. That's probably why.
11. Is that 36? 11:36?
46.
46. $12.44. There's our first official catalog of time and voltage. And then in the closed loop system, to see if it's quote unquote working, that's all you really need to know. But this is the trifilar. A lot of the closed loop systems aren't run with trifilers. So this is the energy that we could be getting. That's pretty good. That's all positive spike though. Pretty much. I mean, well, the equilibrium line is not lined up with the center line. And it's a little bit below, but all the spikes are pointing to the positive range. Even though that's equally positive and negative. You can kind of tell that the line is starting in the negative zone. So we're just going to get a real quick, when that changes to 4.3, I'm going to check the time and we'll get a guesstimation on how much the voltage is dropping, how slow it's dropping in this range. Because when I was messing with the pot, it went from 12.62 down to 12.52, like within 10 seconds. So that, I'm not interested in all that.
You have to ask, what are we doing here?
Here we go. What time is it?
11:49.
11. 49. So that's 3 minutes.
For 1/100.
Yeah. Oh, it went back up though. Alright. That's a good sign, I think. So it's at a flux pattern. It's up right at the bottom of the 44 well. And then it's going to start
Yeah, so it's crossing.
Yeah.
It's going down.
the transitional period.
Josh Ullman is in the house.
Hello, hello. Sorry, what was that you were asking me when I asked the time?
What are we doing here?
Ah, we're doing a closed loop system. This is a pulse motor. It's being recharging and running off of the same battery. So we're going to say about every 4 minutes it goes down. So I'm going to mess with that pot just a little bit more. See if we can't get the numbers a little better.
Did you get better performance out of this one or the wheel you were using yesterday?
I would say that this one, if speed is what counts, this one is way better. Way better. Like, no comparison better. And now it's going up phenomenally that I changed the resistance. That's awesome. So we're going to go 1150 was at 12.43, and now it's at 12.46. But I think it's going to go down, starting to go down already. Because as soon as you, like, when you first adjust the resistance, it'll go up a lot. That's sweet. 11.46. Closed loop system. So there's 12.46 volts going through the system currently. I want to hook a signal generator up to this, but I know as soon as I do that the cost is going to go through the roof. Generation goes up a little bit as well, but the cost is going to be more than we can compensate for. So I'm not going to do it. Alright, the pot is basically off now. And we're now on our descent. We're at 12.45 volts.
Yeah, it's just great work.
So I got a thing that I do want to try, and that's hooking up the 20 and the 18 gauge strand in series and have it be a bifilar coil that's twice as long. Because the length of the wire matters a lot. It's probably one of the only things that really does matter. Like how long your wire is really important. Because at like higher voltage, the thickness doesn't really matter as much. Um, but we're gonna get our reading here. It's 11:53, 12.45. When it goes to 4.4, I'm gonna shut it down, and I'm gonna connect the two wires. I'm gonna hook it back up and start it up again. Still going. Nothing outlasts the Energizer pulse motor. This might be good. I don't know. Do we need to see what about all that anyway? 12.45. Because I mean, when I hook the two wires together, the only thing that we're really going to lose is the O-scope reading. We really don't need the O-scope reading because it's a closed loop system. All we really need is the voltage that's in the system. Alright, so we got our pulse motor here. It's got 3 magnets in the rotor. The rotor has ceramic bearings. It is being run by the SSG from kenergy.store. The power supply is a 20 amp hour 12 volt battery, which is also being charged by the SSG and run by the SSG. That is your closed loop system there. You got a cap bank in the middle with AC caps on one side, bridge rectifiers in the middle, and DC caps on the other side. So that basically takes all your output from the SSG and sends it to the energy that'll go right into your battery. Although it's probably already set up that way, you want to send it through some capacitors to change the chemical, have it go through a chemical change. And then it goes into the battery and it gets chemically changed again. So it makes it stretch out. You know, it's like when you melt butter. Or I would like to say it like you're putting butter on a waffle, or you melt your butter in the syrup and then you put your syrup on the waffle. 12.44. What's the time, B?
158.
58. So that's 5 minutes for that one. And I'm noticing that this is very sporadic on how it's going down. It's never the same twice. And I think that's because every time it goes down one, it adjusts the speed. Alright, I'm going to switch it up real fast. Really, really fast, man. I'm going to switch it up.
Which type of motor are we using here?
It's a DC brushless motor. Vertical setup. It's an SSG for the drive. So, if you're looking for me to say Bedini, I'm not gonna say Bedini. Bedini would be disgraced by what's on my table. So I'm not gonna allude to that because that's not the truth. The SSG, this is the only part of this thing that's Bedini right here.
I'll be right back.
And that's from kenergy.store. Alright. So yeah, we're gonna make the series connection. This should be fun. And I mean, even though this thing looks like it's wobbling all over the face, that's an optical illusion. This black disc is absolutely straight. What you see is a little bump of tape that's holding the magnet in there. It's just delicately holding it in there. All you see is the tape. Any lump or bump or wibble or wobble that you see is the tape. And it is an optical illusion, and that's what it is. Now, do we want the 18 gauge to be primary? Which means it comes first. I think we do. I think we want 18 to be primary. No, we'll have it the other way. We'll have the 20 gauge be primary because I think that'll make the entire length 20 gauge. Because I think when you put the smaller wire first, it bottlenecks to make everything after that the smaller wire. Virtually, yeah. So
57 voters,
nice.
68% yes. 2/3.
Great. Thank you for participating in the poll, ladies and gentlemen. Thank you.
Goddess says hi.
Hello, hello. All right, so now we have our should be interesting. Whoops. Come on. All right, we're gonna just grab all this stuff up here like this.
Ooh, do we have a wiring diagram?
For this, no, I've changed it 8 times during this presentation. I do not. I can make one though. And I won't be judged by my diagrams either. So don't even try. But yes, I can make you one. All right. How is this? Oh. This is our oscilloscope. I mean, the only reason I said it like that is because the last guy that asked me for a diagram said that he was gonna, you know, use it to determine for himself whether or not what I was doing was real. No, thank you. Not even interested in somebody's gonna judge me like that. Okay. Or you can just say no. No, I'm not certain diagrams. So apparently, it was working better the other way. Oh, it went up. I'm leaving it. That's a good sign.
Nice.
Turn it off. Now. Yeah, she's all playing Robin Thicke. I don't need any like copyrights on this one. Turn it on. All right. So this is going a lot slower, but all right, we release. Let's look underneath this thing and see. So I'd say it's about 150 ohms right there, maybe 200. Now there's 100, maybe a little less. you want to get the magnets like right dead center in the coil. So, and I mean like this way that the magnet field spreads around the magnet, it's like the perfect size coil, like bobbin, like the width of it is like perfect for saturation purposes.
First ask, hello guys, what are we trying to do?
This is a closed loop system. The battery over here is running the pulse motor through the SSG, which is running a bifilar coil with 32 gauge trigger and a bifilar drive of a 20 and an 18 gauge. And then the output is connected to a cat bank, which is then connected to the battery that I'm using to run the whole thing. We got a potentiometer of 25 watts. It's got 100 or 1000 ohms. It's about a 3/4 turn pot. I'm thinking I want to hook up this meter to the battery instead of this one, because why do I want to do that? Because I think it goes to the 1000th instead of the 100th. Do I really want to just mess everything up right now? Yeah. I think we can do that. Oh my goodness. Well, I'm gonna untangle all this stuff real quick. Alright, this meter is great. I really like it a lot. But I think this one will go to the 1000th instead of the 100th. We will see. Oh my
20 legs.
God. Nice. Woohoo! No, no 1000, but we got a nice 12.40 reading. And nothing else is registering, so that's obviously showing that we're hooked up to the battery. That's what that means.
Bruce says, what kind of help do you need if I want to help you from home? I have knowledge of electronic, most mechanic, and also some test equipment like power supply, oscilloscope, tester, and signal.
what I really need help mostly on is exactly this right size coil that I'm gonna need. Because I think that's mainly where my problem is the coil isn't generating enough back EMF to overcome the system. And I'll give you a scope, I'll scope it out for you. It's a really tiny coil. It's 600 turns of 18 gauge and 20 gauge, and then 300 turns of a trigger coil. Somebody unplugged my power supply here. There's the coil. So it's really small. All right, I had to get my my view up to par here. It was a little backlogged. All right, screw this in. So like, I mean, the data logger is very useful. I could use a data logger because I'm kind of lazy and I don't want to log all the data, but I want it logged at a certain time, or when a certain event happens, I want it to start logging. You know, things like that.
Josh Evans says, is this, oh no perpetual motion.
Oh no. No, you even seen it right here. It went from 12.40 to 12.39. Boy! There it is. Oh, you can't see it. Let's get it over here. Oh. Can't even hold the coffee in my hand. Everything's so loose.
Okay, I understand you need help to build a better coil and have some log on
Yeah, we need we basically need the not to be too long, but to be long enough to get a nice negative spike off of it. Because I mean, I make some pretty good coils for speed and instantaneous pickup and all that stuff, but they're not designed to for longevity to overcome what it costs. They're not designed to do that. They're very small coils and they're not designed to do that. What's the point? Yeah, shush. This is the closest one I got to being a legit coil to run one of these things, but it's not a bifilar. It's a single file, and the bobbin's printed with iron infused PLA. I apologize for those who have been here for a little while. Actually, I need to readjust this whole thing, so I'm going to take this out. Screw that in a little bit. Put it back in the slot here. Zoom out. Angle down. Perfect. I know you can't really see that very well. Maybe you can. I don't know. I can't see it well in the camera. It says 12.39. That's how many volts are in the system. All right, I think I'm gonna just tighten up that pot just a little bit. Maybe we'll get 12.40. I don't know. Usually when you tighten it up, it goes up a little bit. The speed did increase. That much I could hear going on. Bells, bells. We gave one back. Pulse motor probes. Oh, we're at 12.38. Oh wow. Okay, so there's your satisfaction. I mean, I already knew that was going to happen, but I mean, if you thought this was perpetual motion, there's the burst of your bubble. 3.8, 12.38. Don't tell me about my bubble. You don't know anything about my bubble. Ooh, 3.9. It did go up that time. $40. Oh, went up 2. But granted, I did just twist the knob a little bit. So is there anybody on right now that doesn't know what's going on here and wants to know more? It's a closed loop system with an SSG drive, 3 magnet rotor, neodymium cubes, N52s. It's got a potentiometer and it's running and charging a 12 volt 20 amp hour battery. This is how much voltage is in the system currently. And I mean, honestly, if I had any analog amp readers, I would hook them up just for the fun of it. But this is the number you really have to know right here. You can analyze all the little things it takes to make this change, but this is the number that matters right here. I would like to know more about how many amps are flowing through this thing, but unfortunately I don't have an amp reader that makes sense right now. I mean, this thing reads amps, this multimeter reads amps, but well, there is a load right now. Let's see. Well, no, it's hooked up to the battery right now. It's not hooked up to. No, I'm not. I'm not going to switch that to amps right now, dude. I'm not going to do it. I would have it hook up to the coil instead of the battery. Because the load is the battery kind of thing. I just know that if the output wasn't hooked to the battery or the cat bank, and it was just connected, or disconnected, I should say, that the amp reading would not be correct. Whatever it showed, it wouldn't be right because you got to have your system loaded for the amp draw to be correct. At least that's what this one guy told me on YouTube. And he was really frontal about it, man. He was just, no, man, you do it this way or you're fake. And you just, nothing you do matters because you don't do it this way. And I'm like, well, huh. I know none of that was true except maybe the part where if you load it down, your answer is going to be different. That's the only part of what he said that was true. And the only part that was information, altogether. And I kind of got that point, like right there. Okay, it's going down. That was about 8-9 minutes right there, maybe 10. Yep, now it's going down because now we've played with the pot to the point where it's just going to continuously go down. Because you can't turn it anymore in that direction. If you turn it the other way, it's going to go down really, really fast. Okay, I know there's some people out there that don't think I know what I'm talking about. Maybe I don't. So we're going to find out. Hold on. Let me turn this back on to get some longevity. See, it's starting to go down faster just with that little tiny click. We'll go farther. So you saw me like put some resistance on there and it doesn't like it. It really doesn't. But see, when I turn the knob back, all those hundreds of volts came back. And why is that? Because I think the volts get caught up in the pot. That's what's really going on here. So what I'm gonna do is I'm going to set up the 20 gauge strand again. I think that's our best bet. Sorry if I'm blocking your view. I
Oh, you're good.
can't adjust that. I'm sorry. All right. We'll clip that.
Seventy-one voters, 73% yes.
Nice. Good for all you builders out there. And if you're not interested in building, kenergy.store has some fully built models that are awesome. Well, we just hit something there. Did we open it all the way up? Not quite. It's about 56 ohms right there, man. That's crazy. So,
56 on
yeah. Way on the one side of the pot, so it's really light. You got this rotor with the 3 magnets in it, right? And you got this one with the 3 magnets in it. And it's missing all this material. See, and I did that on purpose, of course. Because this one's 100%, this one, solid plastic. And this one is got like 15% infill, and it's very light. So I wanted them to be different, different as possible. That's awesome. But they do virtually the same thing. They're both 120-degree rotors. This one's got the good stuff, though. The one that's on there right now has got the ceramic bearings.
don't build pulse motors, but I built a semi-successful reed switch motor that I put up on my own kit. Josh,
Thanks, Josh. Hell yeah, man. I'll check that out. I've built quite a few reed switch motors. And personally, I like how the reed switch is, the output is a little bit different. It's a little bit more crisp. A little bit more solid. That's how I would call it. This is my favorite type right here of the real reed switches. But for high frequency reed switches, you got this one right here. It's a reed switch because it's got the two input and output. There's no third one like a Hall effect has. I heard somebody try and call this a Hall effect sensor. It is not a Hall effect. It is a reed switch. This right here is a proximity switch or a Hall effect sensor. It has 3 input and output, and it works with the transistor base. So does a reed switch. A reed switch will work with the transistor too, but this one is designed, has a special cord that works with the transistor. So that's awesome. And it's a proximity sensor, not a switch. Sorry, I said that wrong. But it only works when a magnet like crosses in front of it. A reed switch is different. It works with the magnetic field, and that can lead your positioning to be quite erratic. And, if I would go one or the other, I would go Hall effect sensor. And I would always have a transistor there, whether you need it, quote unquote, or not. No, that's not true, man. I love running it raw electric, dude. Raw electric is great. I just learned that you can actually run a transistor with a reed switch or a Hall effect sensor or a trigger coil. So I got excited. But no, man, I mean, what you're saying is absolutely legit. There's my homemade switch. And this sucker, you just plug it into one end and plug the other end into the other end and let the magnet kind of move the little screw back and forth, and it'll clip on that. It's awesome. It's not high frequency though. It's really slow. 12.3. That went pretty far though. 12.33 now. Dang. It goes for so long you think you're going to get it, and then it's like, you're not going to get it when it doesn't happen. So you don't I thought that was going to work yourself. But I do that to myself all the time. It's part of doing this. When you're doing stuff that everybody tells you isn't going to work, that's part of doing that. oh, I thought this would work. Yeah, I thought this would make it happen. But you know, I went in actually saying, I know this isn't going to work. I'm going to try a few things. And honestly, how long is it going to last for? Like that 12.33, how long is it going to be 12.33 for? You know, how long is that going to last? And that's basically how I break it down by the hundredth of a volt for the closed loop system. I want to do it by a thousandth, but I can't seem to get a thousand. Oh, wait a minute. Let's see if we go to millivolts. Oh, overloaded. See? I think that's great though. It'll go for a long time. I think it will go for at least a day, the way it is. But I think making the coil that'll generate a little bit more than this one is, without sacrificing a tremendous amount of speed. You know, it can't really be a give and take. It's got to be a take. You can't give anything up here. And if you don't think a take situation exists, try having kids. Which of course would be the give on your part. Okay? Because let's just say, for example, you have a birthday party for one kid, then the other kid breaks his ankle later on that day, and you're like, oh man, all I want to do is lay down. I just did a birthday party for my other kid, and now we got a kid in. But no, you take that kid to the doctor, you get him patched up, and you don't go to bed till frickin' 3 in the morning because you're in a give situation. Okay? That's what we need for the pulse motor, except he's the kid. The pulse motor is the baby. And the baby needs to take, and just have, God needs to be good with that. Or whoever the higher power of this stuff is, you know. I'm just centering it, seeing if we can't get more juice off being centered. That's like perfectly in the center. That's awesome. I'm just blown away by how fast it goes. I mean, I've seen ones go a lot faster, and I mean, I got a neodymium sphere here that can blow this out of the water. Uh, that's a that's a you know, that's a north-south field. Uh, one magnet. Of course, with just the one magnet, you always have two magnets. You have your north and your south. But it's not really like that. I mean, it is like that on a very basic level. But I'm telling you, the sphere will cut this up. It'll blow everything away because it's so fast. And it's the best setup you can have because it's one magnet. In order for this wheel to demonstrate the power of one magnet, you need two magnets to demonstrate that power at 180 degrees. And then you have a north and a south, or a north-north. See, with the wheel, you can make it a north-north. with the sphere, you're north-south no matter what, and it just works. It's so cool.
Got another second.
Yay! Yay! All right. So there's the neosphere. If I just place this on the coil that's underneath the pulse motor right now and spin it, you know what? Bro, what if I do that instead of using the wheel for the closed loop system? I never even thought of it.
Oh,
I don't know. Maybe I'll try that later.
yeah, I don't know. I don't know. That's experimentation in its best. And I don't know is okay.
Yeah, I don't know is definitely where you want to go if you don't know. And I mean, seriously, if you've only tested it one time and it worked that one time, you don't know. You need to test it two more times at least, and it's got to pass at least one more of those times.
What in the Tony Stark going on here?
Oh man, I don't know. He'd probably be pretty insulted. He'd be like, "Hey man, of the 8 things that are not in use in this room, one is me and the other is you in a spangly outfit," kind of Tony Stark thing.
Yeah.
12.32. We're still going down. That's awesome. But we're going down slowly. I want to try the Neosphere. I think I'm going to do that. The only problem with the Neosphere is I got to hold it the whole time. Like make sure that bowl doesn't spill over. I don't have any acrylic casing or any, $50 thing that I would put around it to just have it sit there so you could see it spinning in there. No, I wish, man, that'd be sweet. You wouldn't be able to see it spinning anyway because it's spinning so fast. That gives me, I just gave myself like 4 ideas on like how to present this Neosphere, you know? I know that Bennett, I can't say the word, man. I can say it the other way. Yeah, I can't. I don't know how. My tongue won't wrap myself around that word. But it's the opposite of malevolent. It starts with Ben. Starts with Ben. So his. Anyway, what was I getting at? He does something. I totally lost my train of thought trying to figure out how to say his name. And that's totally on me. The benefactor.
Yes. The word. And then it's above. Yeah. It's the other word.
I think here. What was I getting at? Oh yeah, the Neosphere. He uses a glass beaker to roll his sphere on his rodent coil, which I think is really awesome. And yeah, man, I like doing that kind of stuff too. And we're gonna we're going to check out exactly how fast the neosphere can go being timed by a trigger coil real quick. And then we're going to see how fast it can go with a kick of signal generator added to that. All right, so we're about at 10. Let's see, it's about an hour and 40 minutes for it to drop 1/10. All right. So I really want to see that. So we're going to disconnect the power real quick. All right, I have two containers. This one and the one that it's in. We're going to start off with the one that it's in. Let's see what happens when I put the power back on. We'll do it nice and slow. Okay. Oh, no. Okay. Dang. There might be a sweet spot that I need to find before that'll function correctly. Okay. Yes, we do want those. Okay. We're going to charge the battery because all that messing around that I just did costed quite a bit. All right. I might hook up the resistance again. The resistor, I mean, instead of the pot, because I think that The issue is the pot. Oh no, there we go. Must have just been a wire that was touching. Alright, so what I think is we need to have like a little elevation right here so that we can get it in the field, because it touching is way weaker than it just being in the field. Alright, let me try that other container though. Haha, woohoo! That was awesome, dude. Alright. There's some ferro fluid that got dried up on the sides of this, and it's coming off on my fingers. We're gonna put this one back. That was really cool though. It was spinning in the corner, and it was just going.
That was neat.
Heck yeah. Alright. But will it work with the battery? That's what I want to know. That'll be 12 volts, but I don't think they'll be like volts from the power supply. I just don't know though. Yay, went up. Woo-hoo. So that will gen. And this is only at 6.38 volts. All right, man, we're good with that. That's a great. We got lots of ferrule fluid on the ball too, so that's not cool. But that is great. Because that ball will run the thing, and I'm sure, well, it did cost 400 milliamps to run the ball. But it costs 3 to 4 to run this too. Let's run it at 6 real quick just to see if we get any comparable data on the charge. We're looking for the amps that are coming out, and right now it's at 300. So right now it's less, but I think it might pick up a little bit. There it goes, 400. It's about the same. Because I think it's about the same because it's 2 magnets versus 3 magnets. It's about the same. Oh no, now it's at 200. So the wheel might be better, actually. Yeah, the wheel, once it gets going, is definitely the way to go. Nice, 81 voters. That is spectacular. Man, I couldn't even get it started with the other way.
82 votes, 77%. Yes. That's cool.
Heck yeah. Thank you very much for participating, ladies and gentlemen. Oh, I do wanna try this. I'm pretty sure it's gonna spin like crazy, but we're gonna try it. It's I'm putting a signal generator on the coil here. All right, so I believe that hookup is going to be good. Looks good to me, but I'm blind as a bat. Hmm. All right. Well, it got a little tight there, and as you could see, something happened. I'm not exactly sure what happened. Oh, the trigger came out. Trigger got pulled out. So that's my fault. I think we're going to call it for today, though. And I'll set it up again. Whoa, where's that coming from? Oh. Yeah, I unplugged the wrong thing. Like, where's that coming from? Oh, that's because it's still plugged in. Right. we're almost done here. Alright, that's good. There are chafed areas on the wire that I made so that I don't have to get them so close together. And then voila, got it close together. Ooh, the transistor does smell pretty bad. And it's hot. Yeah, all right. we blew the transistor right there. I can already tell. I feel it. I just want to make a confirmation and plug it up to the power supply. And turn it up a little bit. Yeah, it's half fried. So it'll still run, but it's awesome. Yeah, it's half working transistor right now, so and that's all I got. Mm-hmm. I mean, I do have all my reed switches and stuff, but that's for another day. And you can see all the transistors lying around. This kind of happens a lot with my experimentation. I got resistors lying around here too, pots. You know, it's not like I don't use resistance. I mean, I don't use it a lot, but here, let's try this. Because these pots, man, I don't know. They gotta be, because if they're all the way one way, when you turn on your stuff, it's like not. Oh yeah, that's way off. And we saw the spark too, so that's bad. Oh man. All right. Well, till next time, ladies and gentlemen. Peace out. Have a wonderful day. Please subscribe. Thank you very much. Bye now.